Question 20. We're given two functions f of x and g of x as seen. Part A, state which value of x cannot be included in the domain of f or g. So basically this is what x value would we plug in that basically breaks maths. It would make this, give you a math error in your calculator, or this. Whenever you've got a fraction, you cannot be dividing by, or you can't have a denominator of 0. So basically, if x is 0, it will break down, so x cannot be 0. That's the value that's cannot be included. I mean, technically, because it says which value of x cannot be included, we could technically say x equals 0 cannot be included. So you could write either of these technically as your answer. Part B, solve g f a equals 3. So that's g of f of a, close bracket, equals 3. Well, f of a, first of all, will be this with an a in it. So I can sub in a like so. And then we're going to have g of that, which means we're going to sub into this formula here our little 2 over a. We're going to have a 2 over a here in the top, and we're going to have a 2 over a there in the bottom, and that will equal 3. So 2 over a and a 2 over a plugged in, so we got that equals 3, and that's the equation we now need to solve. So having many fractions inside a big fraction is not nice. The fact that we have an equation means that we can deal with them quite comfortably if we multiply both sides by something that will get rid of this blue denominator to start with. So if I multiply both sides by 2 over a, this is what's going to happen. I will be left with the top of the fraction on the left hand side. The other side now has to get multiplied by this 2 over a, and when the dust settles, I will end up with this. Now, I have another fraction that I now need to get rid of, actually two of them. Both of them have a's on it, so I multiply top and bottom here. Sorry, I multiply both sides by a, not top and bottom. I multiply both sides by a, making sure that all of both sides get multiplied by a. These will cancel quite nicely, leaving us with a 2 and a 6. And the one in between will turn into an a. And then from there I take away 2 from both sides, and I get a equals 4. Okay. Part C, express the inverse function g power minus 1. It's not really a power minus 1, but it looks like it, in the form g minus 1x. So g of x, first of all, is this here. First thing I would do is write it out. You can skip to the next step I'm about to say as well. Just to make it easier to deal with in rearranging, rather than call it a g of x or an f of x or whatever your question gives you, we turn that into a y, first of all. So you could jump to this step straight away. Then the next two steps, some people do it in reverse order. It doesn't matter. It's just whatever you're happy with. For me, I like to reverse x and y because of the fact that we're dealing with inverse functions. The roles of x and y are reversed, giving us this, and then make y the subject. So what some prefer to do is make x the subject here, and then swap the letters, tomato, tomato. In order to make y the subject, first of all, I want to get rid of this fraction. So times both sides by y gives us this. And then I got to get all the y's on the same side. So if we take away y from both sides, I'll be left with this. These two terms do not mix. I need to have a y equals something before I can then rewrite it in function notation. So I force these two things that won't mix together by taking y out as a common factor. So the x and the minus 1 that wouldn't mix are now inside the brackets like so, and then I divide both sides by that bracket by x minus 1 in order to get y by itself. Once we have y on its own, we then rewrite it using inverse function notation. So the inverse of g is 1 over x minus 1. Done.